Okay, this is Medgemma submission for Kaggle competition. It's titled Terraphim Clinical Pipeline Graph-Based Safety Gates for Medgemma from class suggestions to specific drug dose evidence. My name is Dr. Alexander Mikolev. I'm an AI machine learning expert, system thinker. I'm a partner in Zestic AI, and I built Terraphim AI, which will be related to the submission. Privacy preserving AI system. So I have a vast background in distributed systems, Rust, complex systems, and knowledge graph. So it's a solo submission where I build the whole pipeline, knowledge graph, multi-agent orchestration, Medgemma integration, harness, and deployment. So why knowledge graph and Terraphim embeddings? So in my previous medical pipeline, which I built under the name of the project The Pattern, and it was a platinum winner of Build on Radius hackathon. I built an engineering marvel, so I've done everything which I wanted there, and it had a question answering, it had T5 summarization, it had large metathesaurus, MLS metathesaurus, and I managed to tweak it in a way where QA large BERT uncased model were performing under 2 milliseconds on CPU before NVIDIA Ampere architecture was released. Yet when I was testing it, I always thought, if my doctor is going to be using my system, I don't want to be a patient. So the problem with large language models that they can hallucinate, and sometimes they hallucinate very confidently, and sometimes they can hallucinate dangerous drug recommendations. So for the last 5 years, I spent time researching building new type of graph embeddings, which enables me to achieve 100% accuracy and grounding in medical industry knowledge. And the industry awakening for the fact that transformers architectures has its own limitations, I see Terraphim or Terraphim-like graph embeddings can be the new type of tokenizer that will drive a new large or small language models. So the problem is that hallucination, and this hallucination can be very confident. So the Medgemma is highly capable model, is way above BERT QA models, and it is highly specific for medical industry. That's where it is already very good. Yet when I was testing it for the pipeline, there are certain cases where it did hallucinate. It is unavoidable due to the maths of large language models. And that's where I build a specific layer which allows me to catch hallucinations, or when it is very vague, it allows me to drive output for the clinician, like GP professional, which will be highly specific and baked by the real evidence. And this is the top 3 cases which are run. So, for example, raw Medgemma runs, and it recommends for BRAF melanoma generic Vega class suggestion, where with Terraphim knowledge graph grounding, you can get a very specific drug and prescription, and it will be evidenced by the medical research. The second case is prescription of the wrong drug entirely, and again the knowledge graph managed to reverse it before clinicians saw the prescription. So the most reliably obviously Medgemma is probabilistic large language models, so when you will be running it and the whole pipeline is fully open sourced, you may find that it's more difficult to reproduce, but overall it is a very solid use case, and particular the impact of it, where there are number of adverse drug events per year in US alone, and 7% of them are quite preventable, and even the small impact on it means there are impact on human lives and the costs. So here is overall Well, actually, let me show you how it actually works. So here is the demo, and this is a UI for the medical pipeline. Obviously, the pipeline can be run separately. And there are multiple patients who are going to visit the specialist. And the specialists have a defined role. They are oncologists, cardiologists, neurologists, and pediatrics. And when we run the pipeline, obviously for the purpose of the demo, it is mocked, but it is if you want to switch it to live mode, and you have a local Medgemma installation via Llama. There is also MLX supported, and Vertex AI is implemented, but I could not test it because of the shortages of the GPU servers. Timeout over 6 hours in both European and US Central. And so this is how it looks. So the patient comes, and the patient, for example, 58-year-old male with identified diagnosis. Then there is an entity instruction, and then there is a knowledge graph query, and there is a validation via another graph, and then we run Medgemma for recommendation, and then we build a safety check. So that's and that's basically it. So that's a rather small pipeline, which allows us to make a huge impact, because the safety guard is managed to catch quite substantial medical errors. Right. So again, entity instruction, knowledge graph queries Named from G, then SPCI guidelines, then we augment inference with knowledge graph, so we embed the main model before Medgemma inference, and then we validate knowledge graph grounding gate before we show recommendation to clinician. So, and that's the example of where this is the system 1 and system 2 architecture, where Medgemma operates as a system 1, fast, intuitive, vast amount of knowledge, very intuitive, and system 2 is a slow, deliberate, evidence-based reasoning. So it's back to Kahneman's system 1 and system 2. And graph embeddings are highly specific, and it is roughly, it's like large regular expression, which is always to have a leftmost longest match semantics. And there is an explanation why exactly that, and it's all based on, in medical diagnosis as well as in other industries, we want to be able to make a very precise and very grounded prescriptions or suggestions. Right, and I think that's that's up for my 3 minutes. I can go for architecture, but submission includes the evidence, the multiple runs, impact analysis, how it can change industry if deployed, and detailed architecture of how each component interacts with each other. So it's mostly based on Rust, except for the small part, which is MLX based inference, requires the Python wrapper because there is no Rust deployment exist. Thank you for listening.